Hello and welcome to lesson 3 of 20 in an Ursa campus breakdown course on introductory statistics and probability. This is module 1, Introduction to Statistics, part 3, Descriptive Statistics, Measures of Central Tendency. Let's get started. Measures of central tendency are the typical or average values of a particular set of data. And in this lesson, we're going to look at 4 different commonly used measures of central tendency. They are the mode, the median, the mean, and the mid-range. We start by looking at the mode, which is the most occurring value. In any data set, the mode is the value or values that occurs the greatest number of times. Features of the mode include the following. Firstly, either quantitative or qualitative data sets can have a mode or modes. So in example 1, we have a set of ratings given to a film by 5 moviegoers after they watch it. And we see the ratings are average, poor, very poor, average, good, and very good. Now in this set of qualitative rating values, the rating average occurs twice, which is more than any of the other values. So therefore, in this data set, the mode is average. In example 2, we have a data set that shows the number of cars owned by each household on a street with 12 households. So we have 12 values here, and we see the numbers there they're not arranged yet in any particular order. And if we look carefully at the values, we see they range from a low of 0 to a high of 4. And if we examine these numbers carefully, we can see that the value 3 occurs 4 times, and that's more than any of the other values. So therefore, the mode for this data set is 3 cars. A second feature of the mode is that a data set can have more than one mode. If more than one value shares the highest number of occurrences, then the data set is multimodal. Example 3 here shows a set of numbers, and this time it's conveniently listed in increasing order, which makes it quicker to see the number of occurrences of each value. So we can see upon inspection that in this set the values 0 and 7 both occur the most number of times, which is 3 times. Therefore, the mode equals 0 and 7, which we can write as 0, 7. Note that multimodal data sets with 2 modes are also commonly referred to as bimodal sets. Another feature of the mode is that a data set can have no mode. If there is no value or values that occurs more than any others, in other words, if all values occur the same number of times, then there is no mode. In example 4, we have a data set of numbers listed here again in increasing order, and we can see upon inspection that all the values occur just once. So therefore, this data set has no mode. In example 5 on the slide below, we're given a similar data set. Here, values do occur more than once. However, all values occur the same number of times, which is twice in this case. Therefore, there is, again, no mode. Next, we look at the median, which is the middle value. The median represents the middle value of the data set and is determined as follows. First, the data set must be put into order, either increasing or decreasing. Then we look at the size of the data set. Now, the data set could either be a population, in which case we would use big N to represent the population size, or if the data set is a sample, we use little n, which is the sample size. The calculations work the same way, and so for the purpose of this lesson, we'll simply use the little n representing sample size. So the determination of the median value actually depends upon whether the size of the data set is odd or even. So we'll start with the odd case because it's the simpler case. If the size of the data set is an odd number, then there will be a middle value, and that median value will simply equal the n plus 1 over 2th value. Now, if n is even, the way we figure out the value of the median depends upon the type of data. Now, if there is an even number of data values, then there won't be a single middle value. There'll actually be two values in the middle, and we want to take the average of those two values. Now, whether or not we can do that actually depends upon the type of data. For quantitative data, this is quite possible because they're numbers, and so we simply take the average of the two middle values. So the median equals the n over 2th value plus the n over 2 plus 1th value. Those are the two middle values. We add them and divide it by 2. If we have qualitative data, now it must be ordinal data to be able to have a median, and n equals an even number, then what we do is as follows. If the two middle values happen to be the same value, then clearly the average of two values that are the same must be that value. So the median will equal this value. On the other hand, if the two middle values are different, then we've got a bit of a problem. There is no specific median because it's not possible to find an average of these two middle values since they're non-numeric. The best estimate of the median in this situation is that it's a value somewhere between these two middle values. In example 6, we're given the following data set that you see in the slide below. We can put that into increasing order as you see on the next line below it. And we have n equals 9 here, which is an odd number. So our median equals the 9 plus 1 over 2th value, which is the 10 over 2 or the 5th value. And you can see that in the ranked data, that is 7. So our median equals 7. In example 7, we're given a data set that you see on the slide below. We put it into increasing order first, and we see that n equals 8 this time, which is an even number. So our median equals the 8 over 2th value plus the 8 over 2 plus 1th value, all divided by 2. So it's the 4th value plus the 5th value divided by 2. So the 4th and 5th values we can see in the ranked data are the values 15 and 27. So we take the average of those two values, 15 plus 27 all over 2, which is 42 over 2, which is 21. So our median is 21. In example 8, we're given the following set of ratings for a university instructor. Now these ratings go in order from very poor to average to good to very good. Those are the possible ratings. And we see that there's a set of ratings that this instructor has received. We put them into increasing order. Now we have n equals 7 here, which is odd. So our median equals our 7 plus 1 over 2th value, which is our 4th value. And looking at the ranked data, we can see that that is good. So our median here is the rating good. In example 9, we have another set of ratings for a university instructor. We put them into increasing order first. Now here we have n equals 10, which is even. So we're interested in looking at two middle values. And they are the 10 over 2th and 10 over 2 plus 1th values, which are the 5th and 6th values. And we can see here that these are the same value. Now this is ordinal data. So if we have two middle values, which is the case when n is even, then we only have a specific median if those two middle values are both the same. In this case, that is what we have. That is the case here. We have both middle values being average, so we can say therefore that the median equals the rating average. In example 10, we have yet another set of ratings for a university instructor. Now this is very similar to the last example. We've got, once again, n equals 10, which is even, and this is ordinal data. So we're going to be looking at the two middle values, which will be the fifth and sixth values. And in order for there to be a specific median, those two middle values have to be the same. Now in this case, we can see that the two middle values are different. The fifth value is poor and the sixth value is average. So therefore there is no specific value for the median. The best estimate that we can give is that the median equals some value between a rating of poor and a rating of average. To sum up, features of the median include the following: all ordinal, including quantitative or qualitative, and all interval or ratio, which are quantitative data sets, can have a median value. However, nominal data sets, whether they're quantitative or qualitative, cannot have a median value because they cannot be ordered. The median value is influenced only by the relative ordering of values within a data set, and in particular only the middle value or values. This means that changes in individual data set values do not change the median at all unless they result in a new value for the middle values or a new ordering that changes the middle value or values. The median is totally unaffected by changes which occur at the lower or upper extremes, even when such changes are significant. Now we look at the mean, which is sometimes called the average value, although all measures of central tendency are averages of one sort or another, because average is sort of a synonym for typical. But the mean is quite often in everyday language referred to as the average, and it's probably the most commonly used and perhaps the most important of all of the measures of central tendency. The symbol for a population mean is the Greek letter mu, and the symbol used for a sample mean is x bar. In either case, whether we're talking about a population or a sample, the mean is calculated as follows, and it's a rather straightforward, simple calculation. The mean is the sum of all the values in the data set divided by the number of values in the data set. And it's something you've probably done a fair number of times before seeing this lesson. So in other words, mu is equal to the sum of the x values divided by big N, the symbol big N representing the population size. And x bar is similarly calculated as the sum of all the x values divided by little n, which is used to denote a sample size. For the examples in this lesson, the symbol x bar will be used, as the data sets in these examples represent samples. In example 11, we're given the following data set with values of 0, 1, 1, 4, 5, 7, and 10. So we calculate the sample mean x bar, as discussed previously, by taking the sum of all of these values and dividing by the sample size, which is the number of values. And we get 28 over 7 equals 4. So we can say that the sample mean x bar equals 4. Features of the mean include the following. Only non-nominal quantitative data can have a mean value. In other words, you can only calculate weighted averages for numerical values that can be put into order. And unlike the median that we were just talking about before, which is not affected by changes at the extreme ends and is actually only affected by changes that produce a change in what the middle value or values are. With the mean, every single value in the data set exerts an influence. I like to think of it as a sort of a soup, where everything you put into the soup has an impact on the overall composition and taste of the soup. So in this particular case here, if you change any single value in a data set, that's going to produce a change in the value of the mean. And in particular, extreme values have a very profound impact on the value of the mean, because if you have very large or very small numbers in a data set, they will have an important influence mathematically on what the value of the mean is. Finally, we look at the mid-range. The mid-range of a data set is defined as the weighted average of the minimum and maximum values. And the formula is mid-range equals minimum value plus maximum value, all divided by 2. In example 12, we're given the data set -3, -2, -2, 0, 1, 1, 1, 2, and 8. So the only values in the data set that we're interested in are the minimum and maximum, the -3 on the lower end and the 8 at the upper end. We simply add them together and divide by 2. In other words, we calculate the average of those two values. So -3 plus 8 divided by 2 is equal to 5 divided by 2, or 2.5. So we say the mid-range equals 2.5. Features of the mid-range include the following. Only non-nominal quantitative data sets can have a mid-range value, because this is a calculation for numerical values that can be ordered. And the only values in the data set that influence the value of the mid-range are the most extreme ones, the minimum and maximum. So this is sort of like the opposite of the median, which is only influenced by what's happening in the middle. The following is a set of 4 practice questions meant to provide a review of the material covered in this lesson. For each of the following data sets, we're to calculate the following if they exist: the mode, the median, the mean, and the mid-range. Question 1, we have maximum temperatures in degrees Celsius over a consecutive period of days as follows: -3, -1, 4, 0, -11, -8, -2, 1, -1, -5. So first we look at the mode. If we inspect the numbers here carefully, we can see that the only number that occurs more than once is -1. So our mode is equal to -1 degrees Celsius. Next, to look at the median, we want to start by ordering the data. So we can order it in either increasing or decreasing direction. As a general rule here, we'll put it into increasing order. The result won't be different if we did it the other way, but for consistency's sake, and because that is perhaps the way we'll most often see data like this put into order, if it is ordered, we'll do the increasing order. So if we do that, we can see that the data goes -11, -8, -5, -3, -2, -1, -1, 0, 1, and 4. And we can see that the sample size here is 10, which is an even number. So we use the median formula for an even sample size. So in this case, it's the 10/2th value plus the 10/2 plus 1th value divided by 2, which gives us the 5th value plus the 6th value, all divided by 2. And we can see here that these two middle values are -2 and -1. So we get -2 plus -1, which is the same as -2 minus 1, all over 2, which equals -3 over 2, which gives us a median of -1.5 degrees Celsius. Next, to calculate the mean, we simply add up all the numbers and divide by the sample size of 10. So it's not really important here whether or not you're using the order data. In this case, we can just add them up in the order that we initially found them. And so we end up with the sum of these values being minus 26. We divide by 10, and so we get our mean equal to minus 2.6 degrees Celsius. Finally, to do the mid-range, we're only interested in the minimum and maximum values, which we have already seen through the ordering are minimum of minus 11 and maximum of 4. So we simply add those and divide by 2. Minus 11 plus 4 all over 2 is equal to minus 7 over 2, which gives us a mid-range equal to minus 3.5 degrees Celsius. Question 2, we have favorite colors as voted by a group of students. And they're in a list as follows: green, red, blue, red, orange, pink, black, white, blue, green, brown, and yellow. So we start with the mode. We have 3 different values here, 3 colors that each occur twice, and that's green, red, and blue. So we would say that our mode equals green, red, blue. We can also say that this sample is trimodal. It's multimodal, and we can further say that it's trimodal because we have 3 modes. Now, this is nominal data. For the most part, we can say that colors are they're qualitative values. They're not numbers. Strictly speaking, there are ways in which colors can be quantified. For example, wavelength of light waves that produce these colors. So in that particular sense, we could think of colors as being either ordinal qualitative data, or even we could quantify it if we converted, say, each color to its numerical wavelength. But in this particular example, we're just looking at these as labels. They're just simply colors that don't have an inherent order, which is probably the sense in which we think of colors most of the time. Most people would think of colors most of the time. So if we consider this data to be nominal, then we cannot calculate either a median, mean, or mid-range. So we would say that there's no median, no mean, and no mid-range. Question number 3, we have the lengths of logs in meters for a group of harvested trees. And the values are 12.7, 19.3, 14.0, 15.5, 16.2, 13.1, 17.8, 15.2, 18.0, 11.4, and 15.1. Now, each of these values occurs only one time, so we would simply say that there's no mode. To calculate the median, we put the numbers in order. And once we have them in order, we can see here that the sample size is 11, which is this time an odd number of values. So there's going to be a single central middle value here, which will be the 11 plus 1 over 2 value. So we get 11 plus 1 is 12 over 2 equals 6. So the median will equal the 6th value in the data set, which we can see here is equal to 15.2. So we say our median is equal to 15.2 meters. To calculate the mean, we add up all the numbers and divide by 11, which in this case gives us a mean of 15.3 meters. And finally, the mid-range, we take the lowest value, 11.4, plus the highest value, 19.3, the minimum plus the maximum, and we divide this sum by 2, so we get 30.7 over 2, which equals 15.35 meters. Question 4, the following set of integers: 0, 3, minus 4, 5, 2, minus 1, minus 5, 0. So here we have the value 0 as the only number that occurs more than once. It occurs twice. And so we say the mode is equal to 0. Next, to find the median, if we order the data from least to greatest, we can see that the sample size is 8, which is an even number, so we're going to have 2 middle values. So we proceed, we take the 8/2th value plus the 8/2 plus 1th value, in other words, the 4th plus the 5th values divided by 2. And here we can see that the 2 middle values are actually both zeros. So naturally, the average of those two numbers, we don't really need to go ahead and do any calculation. We know that the average of 2 zeros will be 0. So we say that the median equals 0. To get the mean, we add up all the numbers and divide by 8. And it turns out in this case that the sum of all of the numbers is actually 0. In other words, all the negatives and positives, negative and positive values cancel each other out perfectly. So we get 0/8, which equals 0. So we say that we have a mean of 0. And finally, the mid-range is the sum of the minimum and maximum numbers divided by 2, the average of the min and max, which is minus 5 plus 5 over 2, which in this case, they also cancel each other out to give us 0/2. So our mid-range equals 0. I hope that you found this video helpful. If you liked it and would like to see more from Ursa Campus, then please subscribe. And also, if you'd like to send your feedback, that's always welcome too. Thanks for watching, and I wish you well with your studies.